The universe witnessed a stunning cosmic expansion before the Big Bang, doubling in size at least 80 times in a fraction of a second. Because of this tremendous inflation, the cosmos became barren and frigid. This is when the cosmos stopped growing in size, and the vacuum energy transformed into matter and radiation, ushering in the Big Bang's era of intense heat and density. This era forged the elemental building blocks that would eventually coalesce into the galaxies and stars we see today. Now, for the first time, the James Webb Space Telescope has peered into the distant past of the universe. We've made a discovery so unexpected that it challenges our understanding of the cosmos. What was there before the Big Bang, and what is it that the James Webb Telescope has uncovered that has shocked everyone? Let's find out. There was a time when the universe did not exist. It was created by the Big Bang, which occurred around 13.82 billion years ago. After the explosion, the universe experienced rapid expansion. This afterglow, mostly detected by radio astronomers, is known as the cosmic background radiation, discovered in 1965. Where exactly did the Big Bang occur? A stick of dynamite detonates in one spot, sending shrapnel into space, but the Big Bang did not occur at any specific location because there was no center and no previously existing void. The fabric of space-time itself manifested and expanded simultaneously in all directions. The universe is often compared to a rising cake with raisins standing in for galaxies. Like the Big Bang, the expanding cake causes the raisins to spread apart, leaving no single point of expansion. However, unlike the universe, which may theoretically go on forever, a cake has a boundary, making this analogy flawed. At the time of the Big Bang, the inflationary vacuum existed, and its energy increased linearly with its volume, doubling when it doubled and tripling when it tripled. If objects were like this, you could rip apart a stack and find endless amounts. Physicists refer to this inflation as the ultimate free lunch. The inflationary vacuum grew bigger and bigger, but it was a quantum issue. Quantum phenomena are inherently unpredictable. Parts of the inflating vacuum decayed at random, becoming regular everyday vacuums. Imagine little bubbles growing in a huge ocean. Inside each bubble, the inflationary vacuum vanished, but its vast energy had to go somewhere. It was used to produce matter and heat, resulting in the Big Bang. In the infinitely large inflationary vacuum, our Big Bang world is just one among an infinite number of such bubbles. All of this began with just a kilogram of inflationary vacuum. The laws of quantum theory make it possible for something like this to materialize seemingly out of thin air. But in what ways does the Big Bang theory fall short? There is no reasonable doubt that the universe was extremely hot and dense at its inception and that it has been steadily expanding and cooling ever since. To accommodate various observations, cosmologists have had to make adjustments to the theory. For example, according to the Big Bang theory, the expansion of galaxies is driven by the attraction of matter. However, if this were the only process taking place, galaxy formation would take much longer than 13.82 billion years. Something else must be at play, an unseen force known as dark matter, which functions like a web of elasticity. In 1998, astronomers found evidence that the expansion of the universe is accelerating. They resolved this by speculating on the presence of dark energy, an imperceptible force that fills space and has an adverse gravitational pull. The reason why the universe maintains a constant temperature throughout requires one further adjustment to the fundamental hypothesis. To explain this, astronomers propose that the universe initially began smaller than anticipated before experiencing an extremely rapid expansion in its first split second, known as inflation. This inflation was caused by an inflationary vacuum, a highly energetic variation of the vacuum that already exists in space. But suppose the Big Bang wasn't the first thing that happened. What then? What was there before, and how does this discovery by the James Webb Space Telescope fit into our ever-evolving understanding of the universe? The James Webb Space Telescope has sent back a stunning image of that tiny location, unlocking previously unknown information about the Big Bang. The telescope's aim is to discover light from the first stars and galaxies, and it was launched on Christmas Day in 2021. The main goal of Webb is to identify the "let there be light" moment after the Big Bang when stars and galaxies first began to form. The potent $101 billion telescope, which has been in development for 25 years, is seen as the 32-year-old Hubble's replacement. Since its successful deployment, it has taken magnificent pictures of galaxies that were created just a few hundred million years after the Big Bang and moments before a star dies. Webb has taken the first direct image of an extrasolar planet. It has also been used to capture stunningly precise photographs of the Tarantula Nebula, a region home to hundreds of newborn stars previously unseen by humans. The telescope has also revealed new hidden stars and the fine structure of enormous clouds of gas called the pillars of creation. The recently released image shows NGC 346, an object that is a part of the Small Magellanic Cloud, a dwarf galaxy that is only 200,000 light-years away from Earth. As is the case in many regions of the present universe, NGC 346 was already well known as a nursery for young stars. These regions are known to have lower concentrations of metals and other elements heavier than hydrogen and helium, which causes them to create stars more slowly than during the cosmic noon. The development of stars is aided by the heavier elements that make up space dust, but due to their low metal content, present star-forming areas are assumed to be largely dust-free. They still produce stars, just not as quickly as they did when they were forming at cosmic noon. However, Webb scans of NGC 346 showed exactly the opposite of what was anticipated: massive dust clouds that hasten the creation of stars. A galaxy like the Small Magellanic Cloud would have thousands of NGC 346-like areas instead of just one, according to Margaret Meixner, the study's primary scientist and author of the new image. But even though NGC 346 is now the sole major cluster in its galaxy that is actively generating stars, it provides us with a fantastic opportunity to investigate the conditions at cosmic noon. The abundance of dust in NGC 346 supports the hypothesis that galaxies during the cosmic midday were similarly heavily covered in dust, thereby providing a close-up artifact of the early universe. Additionally, it implies that NGC 346 may be creating planets in addition to stars by accreting them from swirls of metallic dust. If such is the case, it indicates that Earth-like planets may have originated at the same time as the cosmic midday, considerably earlier in the history of the universe than previously thought by astronomers. It is indisputable that the new Webb image is another stunner from a machine that has been in orbit for just over a year and has done everything its designers and mission planners have asked of it. This is true regardless of the chemistry and stellar physics at play. This stunning image joins a growing collection of breathtaking cosmic panoramas transmitted to Earth by the telescope. The James Webb Space Telescope has also allowed scientists to peer back into the universe's infancy, where they made a surprising discovery. 6 huge galaxies that existed between 500 million and 700 million years after the Big Bang that started the universe were now discovered by the Satellite Observatory. This revelation has totally changed how scientists currently think about how galaxies came to be. These objects are much larger than anyone anticipated. When looking for galaxies in this early stage of the universe, scientists expected to find only tiny, young, newborn galaxies. Instead, they found galaxies as mature as our own. The telescope uses infrared light to examine the universe because this wavelength is undetectable to the human eye and is able to pick up the feeble light emitted by old stars and galaxies. The observatory can literally look back in time to around 13.5 billion years ago by gazing into the faraway universe. What many of us had believed to be established science has been upended by the discovery that massive galaxy formation started extremely early in the history of the cosmos. These objects, which we have colloquially dubbed universe breakers, have thus far lived up to their moniker. Scientists need to reconsider how galaxies started and evolved, since the galaxies are so enormous that they disagree with 99% of models describing early galaxies in the universe. According to the prevailing idea, galaxies started out as little clouds of stars and dust that developed through time. This casts doubt on our current understanding of how early galaxies formed. It's also possible that the galaxies found with Webb's data are something else. It's important that we keep an open mind about what we are seeing, since this is our first glimpse back this far. Although the data suggests they are probably galaxies, I believe there is a chance that some of these objects could actually be hidden supermassive black holes. Whatever the case may be, the quantity of mass we uncovered indicates that the mass of stars at this moment in our universe is up to 100 times more than previously assumed. This is a remarkable shift even if we reduce the sample size. There are many reasons why astronomers could have been mistaken. Perhaps the methods by which early stars originated were significantly more effective than we previously believed, deceiving Webb into thinking that the stars in these galaxies are older than they actually are. Alison Kirkpatrick, an astronomer at the University of Kansas who studies galaxy evolution, wonders if cosmic dust in these galaxies might be present, or perhaps cosmic dust was just different. On the other hand, the James Webb Space Telescope recently discovered and verified the oldest known galaxy. The current record may not last long, according to astrophysicist Brant Robertson, who contributed to the discovery as part of the JADES team. The telescope's strength is such that it is anticipated that even more ancient galaxies will be discovered. The JADES is an advanced deep extragalactic survey, and Webb's most ambitious mission is led by Robertson of the University of California, Santa Cruz. A galaxy located more than 13.3 billion light-years away was found as a result of the survey, 320 million years after the Big Bang. Robertson's team has so far found 2 galaxies from a period when the cosmos was only 2% as old as it is today. Despite being 100 times less massive than the Milky Way, one of them is creating stars at a rate similar to that of the Milky Way. The heart of this galaxy is beating rapidly, so it truly is like a hummingbird, Robertson added. A team led by astronomer Erica Nelson of the University of Colorado Boulder is looking into the possibility of 5 enormous galaxies that may have grown too quickly after the Big Bang. Nelson claims that if the discovery is verified by future observations, it will undermine a key tenet of our understanding of how the universe was born. Finding things that we didn't expect or that we can't understand is the most fascinating aspect of this telescope, of this amazing equipment we put in orbit. Because of this, our concept of the universe needs to be updated, she said. Over the following years, Webb will likely make even more discoveries. The observatory might last up to 25 years, according to Matt Mountain, president of the Association of Universities for Research in Astronomy, AURA, and the manager of Webb's operations for NASA. Mountain claims that with Webb there is no empty sky. Given that the infrared light captured by Webb is not visible to the human eye, Alyssa Pagan and Joe DiPasquale employ a rigorous scientific process to convert Webb data into visible light photographs. When Webb captured photos of the cosmos, Pagan and DiPasquale were among the first individuals in history to glimpse them. "It is a great honor and it does blow your mind every time," remarked Pagan. Even seasoned researchers are astounded by some of the revelations. Dan Milosavljevic, an astronomer at Purdue University, focuses on supernovae, the stellar explosions that created the universe's initial heavy metals from hydrogen and helium. Milosavljevic claims that Webb provides never-before-seen levels of clarity near the epicenters of these explosions. "The iron in our blood, the calcium in our bones, and the oxygen that we breathe are all products of supernova explosions," Milosavljevic explained. "Supernova explosions are the factories that produce everything." The Webb telescope serves as a constant reminder of how little we understand about the cosmos, even as it aids astronomers and astrophysicists in their research, according to Mountain. Mountain cited the example of dark energy and dark matter, 2 substances thought to make up nearly all of the universe but about which nothing is known today. "We are fortunate if we can even comprehend 4% of the cosmos." Suddenly, astronomers' foundational knowledge of the cosmos seemed to be under attack. The standard model of cosmology, our best hypothesis about the beginnings and composition of the universe, doesn't account for what Webb found. Thus, it might be erroneous if the beginning looked like that. However, astronomers have come to believe that the theory can account for the unexpected findings of the new telescope. Some of the galaxies seen by Webb are consistent with those found in recent standard model-guided computer simulations. Scientists are deep in study at the moment, waiting for new spectroscopic data to arrive this spring. The need for primordial starlight has never been greater, and neither astronomers nor theorists, those who study cosmic marvels and those who attempt to understand them, can predict what they will discover when their work is complete. It will take at least 5 years for us to get used to the new universe that JWST has revealed to us. Thanks for watching another episode of Astral Voyager. While you're still here, make sure to click the video on your screen for more mind-blowing videos about space.